So this is figure 9.10, which shows the trend in abundance and also biomass with depth as we go from shallow water on the continental shelf down to the deep sea and abyssal plain. If we look at panel A, we can see the trend in log abundance in terms of number of individuals per metre squared for different groups of organisms. So this covers bacteria, which are the black dots, meiofauna, macrofauna and megafauna. And for all of these groups, what we can see is that the trend is negative. In other words, the number of individuals per metre squared is decreasing with depth. Now the reason for that is that the shallow coastal seas are those which are most productive, with terrigenous inputs into the system and also primary production in coastal waters, driving a large abundance of food for the organisms, hence promoting biomass and also abundance. As we move deeper and further away from the coast, then the environment becomes much more oligotrophic, and so the number of organisms per unit area that can be supported is far lower. We also see this trend replicated in biomass. The important thing to remember is that these scales on the y-axis are log units. So although they're shown as straight lines, they would be curvilinear and extremely steep. So the actual change from shallow to deep is very pronounced indeed. A slightly different trend, though, is seen in terms of the mean mass per individual for fish, which is shown in panel C. And what we see is that the deeper we go in the sea, then the larger the average individual mass of fish. In other words, we tend to encounter fish with a larger body size and mass in deep water environments. This is almost certainly related to patterns of growth and also the age that some of these deep sea fish can achieve, some of which are very long-lived indeed, and some of which reach very considerable body mass sizes as well.